All right, almost forgot. So we're going to continue what we left off on alpha 57, which is to find inverse and identify domain and range along the process. Okay, so number 5, we have f of x equals to 2 multiply e to the power of x plus 3. Okay. In this question, of course, we still have the same task, which is to find the inverse, right? Along the way, we also will identify, and we're going to do the graph. We're going to see the different aspects of about these functions. And obviously, this is e to the power 2 times e to the power x. We can certainly graph this, right? Multiply by 2, shift up by 3, and multiply by 2, make it more narrow. We'll go closer to the y-axis. So we understand that, okay? And in terms of the graph of this function, right? So we start with e to the power x, right? And the input is x given to e to the power x. And then we multiply 2 times e to the power x. And then we're gonna add 3, right? So that's the process, that's a process. So when we graph this, and we can start with graphing e to the power x, which we have done the detailed graphing with the points being plotted. And here I'm going to make some adjustment, right? And over here, I'm going to make it like a little narrow. Oops. What happened there? Oh, never mind. I should put a -2. That's why it's cut. Okay. That's e to the power x, right? And I can make this a little bit narrower. Okay, so that's the picture. That's a picture for e to the power x. That's a picture for e to the power x. And of course, from e to the power x, and we will multiply by 2. Okay, so let's see what happens if we multiply by 2. Our anticipation is that it's for the same input, the output is going to be doubled, right? So that's going to make it taller or more narrow. So to see if that's confirmed, right? 2 times e to the power x. And suppose I'm going to make it a blue. Okay, so let's look. You see, indeed, it's more narrow, right? Everything, all the output is doubled, right? So that's how we get the 2 multiply e to the power x, right? So with the basic picture we had about e to the power x, we can do more, right? So all the output is doubled, right? You see, to understand the meaning of a doubling, right? For the same input, right? E to the power x, the output is doubling the output from before. Right? For the input of 0, right? The output is double. The output before was this much. This much, that's 1. And now the output at the same for the input is twice, right? You can see the purple, this guy, let me change a different color. So this is a doubled. This is a doubled on the blue. This is a doubled, right? So the red is doubling the purple. And this is happening everywhere, This is happening everywhere. For example, add 1, right? Add another input 1. The input was 1. The output for 1, of course, we know that's E, right? The purple would be something like this, right? That's an E. On the output for 2 times E to the power 1, 2 times to the power 1, that's going to be on the blue. So that's going to be on the blue. So that's what we're getting. So the red, which is the output for the same input 1, you can see the red is twice the height of the purple. So that's the doubling effect. That's a doubling effect. Got it? So next, we're going to shift the whole thing up. Okay, we're going to shift the blue curve up by 3 units. By 3 units. That's what adding 3 is doing. Okay, that's what adding 3 is doing. So now we're gonna do the 2 times e to the power x. And based on that, we're gonna add 3. So our final curve, I'm gonna use red. Everything is shifted up by 2 units, by 3 units, right? The y-intercept is shifted up by 1, 2, 3 units. You see, everything is shifted up. Are you with me? Are you guys with me? So with the basic picture, e to the power x, we can do a lot of things, right? This is adding 3. So every output here, so these points, okay? So all of these points, right? Let me use dots. And this point and that point, they all shifted up by 3 units, right? Shifted up by 3 units. You see this dot that was here, that was shifted up by 3 units. So this is 3 units. This is 3 units, okay? So everything shifted up by 3 units. But anyway, so that was just review of these transitions and shiftings. So now we got the picture. We got the picture, right? So finally, we got this red curve, right? So we can even guess that our inverse function is going to be symmetrical with respect to that blue, that green, right? We're familiar with. There's something that's symmetrical with respect to that blue. If I am making some adjustment to the scale, right? So let me clean this up, right? There's something on the other side, which is symmetrical with respect to the red, Okay, so finally we get the curve, which is the red curve, and I'm going to remove these two. So that's our final. So we expect there's something over there. Okay. What it is, we will find out. Okay, so let's find the inverse, right? Before we find the inverse, we know the domain and range for this function, don't we? Right? The domain and range for this function from the picture, it tells us the domain is all real numbers, right? It's all real numbers. And the range, let's look at the range. Let's see how we decide the range. Because e to the power x is larger than 0 for any real number. For any real number x, right? Then we multiply this guy on both sides by 2, right? Multiply by 2. Then 2 multiply e to the power x is going to be larger than 0, once again, for any real number x. And if we take this guy, we're adding 3 on both sides, right? If we're adding 3 on both sides, So that's going to be larger than 3. So that tells us the range. That tells us the range. Okay, so the range is the whole thing, right? It's larger than 3. If you like interval notation, right? If you like to have interval notation, that interval is going to be from 3 to positive infinity. Okay, so that's domain and range. So now let's find the inverse function. So finally we get to find the inverse function. We're going to take the domain and range with us. We're going to take the domain and range with us. Okay, let's see how we find the the inverse function. So we take that function, right, with the domain showing. Okay, so this is the y, right? And swapping x, y. These are the steps we're familiar with, right? We've been consistently doing this. The swap, x becomes y, y becomes x. Right, the swap also caused the swap of the domain and range. So inverse functions, domain and range. The domain would be the range of its inverse, right? So the domain is going to be x larger than 3, and the range is going to be all real numbers, right? So the swapping of x, y caused the swapping of domain and range. And now we're solving for y. Okay, we're solving for y. We're solving for y. How do we solve for y here? Right, y is here. Let me make the fonts just a little bit larger so you can see better. Do you see better this way? Okay, so now we cannot apply the definition of logarithm. We cannot apply the definition of logarithm. We cannot apply the definition of logarithm yet. Why? Because if you look at the definition, right, the definition of logarithm goes like this: log base b omega is equals to triangle, right? If and only if b raised to the power of triangle is going to be equal to the omega, okay? And of course, we always be aware that b must be positive and cannot equal to 1 in the circumstances. We cannot apply this definition directly because we have an addition. So if we can manipulate it somehow, right? So we're going to subtract 3 on both sides, which is 2e to the power x. We have an exponential form, but there's a number in front of it. So we're going to divide both sides by 2. Okay, so we're going to divide both sides by 2, and that's multiply both sides by half, right? So this multiply by half, right? So divide both sides by 2 is the same as multiply both sides by half. So by this time, if we switch side, we have, you don't have to switch side. It just look a little bit easier. So e to the power x is equals to half of x minus 3. Now we can apply the definition. Let's see how we apply that definition. Right, we have e to the power x, right? In this definition, which part is a power? Well, the part that's a power is base e, and that's e. So this is e. If this is e, this is ln, right? And so we don't have to specify the b anymore because b is automatically not equals to 1 larger than 0, right? Excuse me. Let's see what is we have e to the power x, we have e to the power triangle, right? But what is x, right? So e to the power of x, e to the power triangle, so the triangle is x. You see, triangle is x, right? Triangle is x, so this is x. Omega, this is omega. This is omega. So omega, e to the power, omega is half. So omega will go here, and omega will go there. Oops. That's what omega is. Okay, and of course, e to the power x. Okay, so now x is solved. See, x is isolated. Oh, wait, what did I get? Y? I'm sorry, this is e to the power y. My bad, e to the power y. Let me do it over, okay? I'm gonna do it over. I messed up, I'm sorry. I don't want to confuse you, so I'm gonna do it over, okay? I'm gonna do it over, e to the power y. For some reason, I put an x there, okay? So let's do it over. We're solving for y. In order to solve for y, I'm going to isolate e to the power y. So now we're closer to e to the power of y. So e to the power of y is equals to half of x minus 3. And half of x minus 3. And then what? And then what? Now we're closer to the definition, right? You look at the definition, right? The definition left and right, you know, let's do it all over again. Okay, so this is omega. And that equals to triangle if and only if e raised to the power of triangle is equals to omega. Okay, because the b is e, so I'm not going to specify the b anymore because I have to immediately change it to e. And this is ln. Okay, so I have e to the power of y, e to the power of y, so triangle is y. Omega, so triangle is y. Omega, okay, omega is half of x minus 3. So omega will be replaced by half of x minus 3. You know, to be on the safe side, if you want to put a bracket there, that would be good. But you don't have to because they're together, okay? Usually they're not going to be confused. But this way is much better. So now y is solved, okay, by definition. So now y is solved because now y is this guy. Okay, so y is solved. If you like to apply the quotient rule, okay, because you can take this and put it on the top. So you can apply the quotient rule. You can apply the quotient rule. If you apply the quotient rule, you can have ln of x minus 3 minus ln 2. Okay, so that's the quotient rule applied. And that's we have already found the inverse. We found the inverse, right? That inverse was domain, you know, f inverse here. The domain is we already know, and that's the inverse function right there. There, that's the inverse function. Okay, so let's look at the graph. Let's look at the graph. let's look at the graph. The graph of this function, right? The graph of it, okay? The graph of it, what would that be? Well, we're gonna start with ln x. I want you guys to be really familiar with these curves, right? And even though we will not be able to cover everything about these functions this semester, but I hope to give you a really good foundation for your continued study. So ln x here, we know the domain and range for ln x, right? X must be greater than 0. But when it comes to graph ln of x minus 3 minus ln 2, this will be a shifting down by ln 2 units. Okay, so it's a natural log 2. Natural log 2 is a single number, and you shift it down from ln x minus 3. So we're going to do one at a time. Okay, so from ln x to ln x minus 3, what kind of shift would that be? Could anybody tell me what kind of shifting would this be? A horizontal shift, vertical shift, left, right, up, or down? Okay, I'm just going to make some adjustment. More adjustment. Okay, so that's ln x. That is ln x. Okay, so from ln x, we can graph ln of x minus 3. Can anybody tell me the graph for ln x minus 3 is a shifting of ln x up or down, left or right? Can you tell me? Can you tell? Could you guys tell? Anybody? Is it right? Is it shifting to the right? Yeah, I think so. It's going to be a shift to the right. Okay, so ln is a horizontal shift. Okay, shifting to the right by 3 units. So I'm going to make a different color. Blue. Okay, so it's a shifting right. You see this point shifted 1, 2, 3. Every point is shifted to the right by 3 units. Okay, and last but not least, we're going to subtract ln 2. Subtract ln 2. You know, ln 2 is a single number. What is ln 2? What does ln 2 equal to? ln 2, if you want to look at the numerical value, it's 0.69315. So the entire picture is going to shift down by 0.69315. There are many more digits afterwards, downward. Okay, so let's see if that's the case. Okay, so our shifting, so let me make it smaller again. Our shifting of the blue, shifting down by 0.69315 units. Okay, so it's from ln x minus 3, the blue curve, minus ln 2. So the final curve is a red. It's a red. Okay, so how much in the unit has been shifted? ln 2. Okay, so everything is shifted down. So every point is shifting down. Okay, every input is shifting down shifting down, shifting down, shifting down. How much is the red bar? The red bar, that's the amount of shifting, is ln2. 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 The value is 0.69315. Okay, of course, the computer did it automatically for us. So one is shifting right and then shifting down. So finally, the curve is going to be ln x minus 3 minus ln2. So now two pictures together. Okay, so now we're going to have two pictures together, right? So we have this blue picture. Okay, and I'm going to remove. Okay, I'm going to remove some stuff. So the final picture is the red. The final picture is the red. So I'm going to delete the other pictures. So we get the red curve. We get a red curve. Okay. Combining with the curve we did earlier, right? So combining with these two. Okay, putting these two together. And better yet, we graph them all in the same picture. Graph them all in the same picture. Okay, so it's a ln x minus 3 minus ln2. Still we have both red. Okay, and I need to make some adjustment for the picture. Okay. But the scale needs to be adjusted. The scale needs to be adjusted, right? So we want these two is about the same. Symmetrical with along the line of along the green line. Along the green line. And of course, I can show you some more of that. Oops. Oopsie. No, I have a typo. This is I meant to be 12 as well. Okay, not 2. You see these two curves are still symmetrical. So to summarize, right? So we see the same feature over and over again about inverse function. Right? So let's summarize. Okay, the function we have in consideration, the function that was given to us was f of x with this domain and range. Okay, so I'm going to copy all of these together. Right, I'm going to copy all of that together. So summary. So this is one function. And of course, there's another function, the inverse function. Right, the inverse function. So if we put them in a table to summarize, okay, so let me put in a table so that I hope that will make it easier for you to see. Okay, over here. Excuse me. The function was here, right? That was a function. And the inverse function we found, that's right there, right? And their domain, range, right? The domain for this guy is from negative infinity to positive infinity. And the range is the whole thing larger than 3. Okay, larger than 3, or in interval notation is 3 to positive infinity. And that domain for its inverse is x larger than 3, right? Larger than 3. And the range, of course, is still from negative infinity to positive infinity. Okay. And what else? The picture. The picture. Okay, so I'm going to graph the picture. So insert a row, right? And the picture we had was for the latter one. And the other one over here, right? We just put it over here. If we put them together, I'm going to make some adjustment to the scale, right? So that's -2. Okay. And the other direction, this is not, this -12, right? And we're going to see some comparison. We're going to see some comparison. So, and this guy, we need to make some adjustment to the scale. So let's make it 10. And over here, it's going to be 10 as well. The scale must be comparable. That make it easier to see, right? So you can see this piece is 2 times e to the power x plus 3, and this other one, so maybe we make it just a little wider, make sure the scales are matching. So that's we get a better observation. Okay, this way we have better observation. So that's 10, that's 12. So this needs to be adjusted to 12. Right? And of course, if we put the pictures together, which we did earlier, right? The pictures together is like that. Pictures together. The picture together, that's just like, okay. And usually we like to graph them in the same picture. Okay. Last but not least, okay, last but not least, number 6. Number 6. Number 6. Number 6. Number 6, we have a G, and we want to find its inverse. X minus 1 plus 2. You guys want to try this? I'm going to give you a couple minutes so you have a head start. You have a head start. Okay, I'm going to be a little behind you. Okay, so what you do is that you're going to first determine the domain of G. Domain of G, right? Range of G. And then we go ahead to find the inverse, right? Which is, we try to find F, right? Find F, which is the inverse of G. Inverse of G. Okay. Or you can also say, just don't use F, use G inverse. Right? We can do that. Okay. After this, we're going to move forward with more exercise on logarithm. Okay. And we will also do the product rule, quotient rule. We're also going to be doing the product rule and quotient rule. But anyway, so let's get this done. Let's get this done. We have a G. This time G is a given, right? So what's the domain for G? Well, to determine domain in G, x minus 1 has to be positive. So x has to be larger than 1. What's the range of G? It's going to be from negative infinity to positive infinity. Negative infinity to positive infinity. If you're not sure, that's not a big deal. That's not a big deal. Let's look at the picture. Let's look at the picture, right? ln x. And from ln x to ln x minus 1, what kind of shifting would this be? Right? And eventually we get to ln x minus 1 plus 2. What kind of shifting would this be? Shifting left, right, up, or down. So this is ln x at our fingertips, right? But most important, we have done the graph ourselves. So we really understand what we were doing. So let me move over a little bit. There you go. So that's ln x, right? That's a little too wide because we need more space. So that's about a decent picture. That's a decent picture. And next, we're going to graph ln x minus 1 because we want to observe the range of ln x. You can see the range for ln x is from negative infinity to positive infinity. It can go as low as possible. It can go as high as possible slowly. Now, ln x minus 1, comparing with ln x, what kind of shift would that be? We know it's going to be shifting. Is it horizontal or vertical? Could I see some answers on the chat or by voice? Okay, you can unmute yourself and tell me what kind of shifting would this be? Left, right, up, or down? What will be the shift? Any volunteers? Marcelo, do you think this is going to be a shift to the right or shift to the left or shift up or shift down? Marcelo? Left? Okay. But we have a different opinion. Do we have a different opinion? Alan think is shifting to the right. Marcelo think is shifting to the left. How do you decide which one is right, which one is left? Right, I haven't pressed the magical button. How do you decide? How do you decide? We have a left, we have right. Is there any answers going up or down? Anybody think this is going to shift up or down? So now we have multiple choices. A is a left. B is a right. Do we have C? Do we have D? Do we have C or D? No? Okay, that's actually a good thing because we have two choices to choose from, right? Left or right. So how do I decide? How do I decide whether it's shifting left or right? Hmm? How do we decide whether it's shifting left or right? That's a question, right? That's a question. If you don't want to be relying on memorization, if we don't want to rely on memorization, what do we do? What do we do? How to decide whether shifting left or right? If because when we rely on memorization, sometimes that really screw us up, right? That's really screwing us up. So how do we decide? The basic thing to do is to plot points. The basic thing to do to plot points. Really, okay. The basic thing to do is to plot points. Okay, so we have ln x. Well, we only have these two functions in our consideration right now. We're going to do the other one later. And you guys all agree this is going to be just either left or right, right? So now we decide whether this is going to shift to the right or shifting to the left. How do we decide? How do we decide? Because the whole thing is shifting left and right, so we anticipate the range is going to be from negative infinity to positive infinity, right? ln x has a range from negative infinity to positive infinity. One of the things you can do, okay, I'm not saying this is the only thing you can do, okay, one of the things you can do is that you take ln x, right? And then you also take ln x minus 1. And you ask this question. It said, if the output is 0, if the output is 0, okay? If the output is 0, right, what do we get? There's a 1, right? In that picture, x equals to 1 because ln 1 equals to 0, right? Yeah? Excuse me. ln 1 equals to 0. 1 is ln x minus 1 equal to 0. 1 is that output equals 0. If x minus 1 is equals to 1. And as a consequence, x equals to 2, isn't it? Do you guys follow me? Imagine this is baloney. Okay, imagine this is baloney. Imagine this is baloney. Right? When baloney equals to 1, ln 1 equals 0. So baloney equals to 1. Right? Yes? If ln of baloney equals to 0, then the bologna is going to be 1 because ln1 equals 0. ln1 equals 0. So now when this guy is x, and that's going to be x. When this guy is x minus 1, okay, then you have x minus 1 equals to 1. As a result, x equals to 2. What does this tell me? What does this tell me? This tells me, because I set them equal to 0, this is the intention is to find x intercept. Okay, because this is basically to find where the curve crosses x-axis. And one place the curve crosses x-axis at 1, and the other one crosses it at 2. In other words, the next curve you're graphing is going to cross the x-axis at what? Okay, ln x cross x-axis at 1, and the other one is going to cross it at 2. So if this point is shifted to the right by 1 unit, is that shifting by 1 unit? Do you guys see that? This is not the only way, but this is one of the simplest way. Okay, so it should be shifting to the right, not to the left. Do you follow me? It should be shifting to the right by 1 unit. So let's see if our guess is verified. So now we can graph ln x, right? ln x minus 1, right? It should give us, let me get a green. So it's shifting to the right by 1 unit. Do you guys get it? So when you're not certain, get a piece of scratch paper to try to figure out. So what are tools to figure out? The definition, logarithm, some common knowledge, such as ln equals 0, ln1 equals 0, log 1 equals 0, log base 3, 1 equals 0. These are your basic information that we can use. So this is shifting right by 1 unit. So that's how we get ln x minus 1. So how about ln x minus 1 plus 2? And this one will be shifting left, right, up, or down. Between these two, what is the shift? Is it shifting left or right, up or down? Could I see some answers on the chat? This is shifting up, right? This is shifting up. I know you guys might be a little bit tired, so this guy will be shifting up. Okay, because this is already a picture. This picture is the green picture, and this thing is telling, this expression is telling us the entire picture is shifting up. Okay, the entire picture is shifting up. So let's see if that's the case indeed. Okay, so the red is shifting as a consequence of the green shifting up by 2 units. 2 units. Okay, so I'm going to give you some more on the y. Okay, on the y. Through these shifting, right? We have seen that there's shifting up from the green. Everywhere shifted up by 2 units. You got it? Okay, so the red is our final curve of ln of x minus 1, and then plus 2. Domain and range. And next, let's find the inverse. Have you found the inverse yet? Have you found the inverse yet? Right? Find the inverse. This was our G. We're going to find the inverse for G. And the steps, right? So we need to be aware of the domain and range of G, right? Domain and range of G, right? Domain range are specified. So when we try to find the G inverse, we go down to the procedures. Okay, we go through the procedures. All right, so do we have a Y? So here's our Y and that's our X. And swapping X and Y, right? We understand why we bring the domain and range with us, because when we swap, the domain and range is already decided for the inverse, even before we find it. Okay, so this swap, we will get X equals to ln of Y minus 1 plus 2. At the same time, the inverse of G is already decided. This has been decided, right? The domain will be the range of the previous. The domain will be the range of G. Okay, so that domain is all real numbers. Okay, and the range what will be the range? The range will be the domain of G, which is for now, we don't have the symbol yet, right? So what we can do, we can put Y under the circumstances, right? In this description, that Y is going to be larger than 1, okay, larger than 1. So domain and range is swapped. Okay, XY swap, domain range is swapped. Okay, and then what? We're going to solve for Y. We're going to solve for Y. We're going to solve for Y here. Okay, to solve for Y, I'm going to bring this down. Oops. Okay, and what are we going to be relying on? Definition again, right? Definition of a logarithm. Did you guys find your inverse? I asked you guys to have a head start. Do you want to try it now? From the definition, base B omega equals to triangle if and only if B raised to the power of triangle and equals to omega. And of course, B needs to be greater than 0, not equals 1, right? Not equals to 1. Never forget that. I keep mentioning this because that's in my mental note and it should be in yours as well. Okay. Can we apply this definition? Yeah. You see, on this definition, you need a logarithm on one side by itself, right? Logarithm on one side by itself. So we're going to subtract both sides by 2. Okay, so we have x minus 2 equals to ln y minus 1. Okay, so ln, we have ln, so the b is going to be e, ln, log base e is ln, and the base is e, right? So we have ln omega here is y minus 1, right? It's y minus 1. So we're going to take that with us. Okay, and you can switch side if you want to. It doesn't really make any difference. So omega is y minus 1, right? Everywhere omega is y minus 1. We don't need to be here anymore. We don't need to be here anymore because E satisfies the required condition. Omega is in place. What is triangle? Ln y minus 1 is x minus 2. X minus 2 is a triangle. And x minus 2 is a triangle. There. Right? So we are closer. So you see, using the definition from here, we get to this place. You guys see that? Get to that place. And y is almost solved. Right? Y is almost solved. So we can add 1 on both sides. So we get e to the power of x minus 2 plus 1. There. Right? Y is completely isolated. And our g, inverse of g is found. Inverse of g is found. Yay. We got it. We got it. And was a domain in range? Was a domain in range? We have it. We have it. We have it right there. Okay, G domain, of course, the domain is all real numbers, G, and now you can replace it by that guy. Okay, and it should be agreeable with our knowledge about the domain and range of the of the function, of the exponential function. Okay. Would you like to graph the picture? Graph the picture, because I want you guys to review this. Don't forget these little things we have done, right? What I would like you guys to do is can you graph this from E? Graph, okay? So your goal is to graph this guy from here, e to the power x. How do you get there? By shifting. Okay, so I want to give you a couple of minutes. Just allow me to step out for 1 minute. I'll be right back. Okay, I'll be right back. I want you guys to graph this, okay, from e to the power x, and graph this finally that one. Okay, I'll be right back. All right, guys, I'm back. So are you done graphing? Okay, you first do e to the power x. Remember, we did all the points we have in the past, right? We don't want to forget about it. And they're very, very useful. They're very, very useful. Okay, so let me make some adjustment to the picture, right? The scale needs to be adjusted as you always have to do when you graph. And over here, I'm gonna make it maybe 3. I can always, do it over. So make this 8. Okay, so that's e to the power x, right? That's e to the power x. And I know I'm gonna have to making some transitions and shiftings and stuff. And then from here, from e to the power x, we're gonna shift to e to the power x minus 2, right? E to the power of x minus 2. So this is gonna take some steps to get there. So what is e to the power x minus 2? What kind of shifting is that? Is it shifting left or right or up or down? What shift would be, what shifting would that be? It's shifting to the right, right? It's shifting to the right. So we're going to shift it to the right, e to the power of x minus 2. Okay, make it green. Shift to the right. Okay. And I probably like to make some more adjustment about this. Okay, so that's shifting to the right. And then finally, what would that be? Shifting up by 1 unit. I think you guys got that. So I'm just going to quickly finish, and so you can take a break. Okay, so finally, we're going to have e to the power of x minus 2. This whole thing is going to add the 1. The entire picture shifted up by 1 unit. Okay, we're going to take a break after we're done with these questions. So you see the red is the final curve. Okay, the final curve. So we have the red here, we have the red before. So when we put them together, right, together G and G inverse. So in that picture, oops, okay. So in that picture, right, we're going to, get rid of some stuff, right? Just keep things simple. This is G inverse. And what is G? Our G that was given. G was given, right? That was G was given. G was ln of x minus 1 plus 2, right? Ln minus 1 plus 2. I still be using the red, right? And in terms of domain and range, everything else, I'm making some adjustment. Y equals to x, that green line of symmetry. Okay, right there. Okay, and I think I'm just going to make this piece a little bit more. So that's 8. Okay, so that's the G. This is the G. This is G, and this is G inverse. Okay, let us take a break. Let us take a break. I know you must be tired, and come back. Oops, sorry. Okay, where they did this? Okay, where they did this? Oh, did I put away that picture? Oh no. Oh, never mind. It's okay. I'll grab it. Okay. So from that picture, okay, from that picture, I'm sorry about this. For some reason, I just removed them. I guess I need to take a break as well, right? And the next picture we're gonna do is the universe, right? So we have the G inverse. They are together in this picture. They're both red, and I'll mark it. Okay, I'll make some necessary adjustment. The green line of symmetry and the scale, the view, right? And there. The scale doesn't seem to be matching very well, right? So we're going to make that visually. That's it. So that's G, or that's G, and that's G inverse. Okay, so let's take a break. Okay, come back at 11:51 a.m. today. Okay, so I will see you guys in 10 minutes, and keep it up. We're getting to the finishing line. Okay, we have 2 more weeks to go after this week. And I will talk about our arrangement for the remaining time of the semester. Okay, just later. Okay, see you soon. 10 minutes. Back. Hello. Hello, everyone. Welcome back. How are you? So now we have done quite a lot of graphing, right? And we're going to proceed to work on alpha 58. Okay, we're going to proceed to work on alpha 58. Okay, alpha 58. We've been in the logarithm for quite some time, right? And so let's get to alpha 58. Okay, so get your paper, pencil ready. And we're going to see how to I deal with these kind of questions. Okay, how to deal with these kind of questions. So we're going to get to alpha 58. Okay, we're going to do some deriving. We're going to be doing some deriving. Okay, how does derive work? Okay, basic, the definition. Okay, we understand the definition goes like this. If we have a log base b, and here's omega, and that equals to triangle, right? If and only if the base raised to the power of triangle, it is equal to omega perfectly. And of course, we require that b is larger than 0 and not equals to 1. So this is the basic requirement. From the definition, right? So here's the definition. We can see that b raised to the power of triangle, but the triangle is this guy. Triangle is the same as the log base b of omega. So if we take this side out with us, okay, and we're going to replace the triangle by what is equal to triangle. Okay, we're going to replace the triangle by its equal. Okay, triangle is the same as log base b of omega. So if we replace this triangle by its equal, boom, that's what we get. Isn't that interesting? Isn't that interesting? I want you guys to do this, okay? I want you guys to do this, to do what I just did. Okay? Are you ready? You want me to do it again and then you do it? Okay, I'm going to do it again. So in this relationship, right? We know they're locked in that relationship. They're locked in that relationship. So I'm going to take this b to the power of triangle, knowing triangle is the same as log base b of omega. So I'm going to replace the triangle by its equal. That's what we got. Are you guys ready to do it yourself? You must do this. You must do this. You ready? Okay, so I'm going to stop the share and you're going to do it yourself. Ready? Go. You see how that works? I want you to see how that's been done, and you can do it too. And you can do it too. Anybody can do it. Okay? You can do it too. I'm not watching you. You do it. Did you do it? All right. Did you see how that's done? One more time. It was b raised to the power of triangle, which is the same as this guy over here. We simply replace the triangle by its equal. Okay, whatever equals a triangle, that's the left-hand side. Replace. But with this action, what is the implication? What is the implication of doing this, right? What is the implication that we have done from the definition to this identity? To this identity, right? What does this mean? What does this mean? Omega is always positive, right? Omega is always positive, right? Well, that's a domain. That's a domain. Omega is always positive. So this is domain. Triangle can be any real number. That's the range of logarithm, right? Triangle can be any real number. And this guy has to be positive. Now, in that relationship, what does that mean? What do we observe here? I'm going to make the fonts a bit larger so you guys will see better. In this observation, okay, what you need to notice that this base b of the exponential form is the same base b as the logarithm form. In front of a logarithm form, there's no other number but 1. There's no other number but 1. Okay, it's just 1 times that. 1 times that, we can remove the 1. Okay, so when these two bases are the same, one is for exponential, one is for the logarithm, when these two are the same, whatever omega is going to be, the whole thing is going to equal to omega. Okay, so let's look at some examples. Okay, let's look at some examples. Let's look at some examples, right? If I change the base, because this is true for any base larger than 0, not equals to 1. Any base, that's what we meant. So if the base is 2 and this is 2, that's going to be true. If the base is 3, this exponential base and log base is 3, and that's going to be true. If that base is 10, right, this base is 10, which is by default, this is a log base 10, and this is true. If this base is E, and that is E, and log base E turn into ln, and that is true. And there will be many, many other cases, as many as you wish. Okay, take another case, is that if this is 7, and that is 7, that is true as well. So all of these are examples of that truth. Now let's see, let's look at something else. Omega, if this omega is 1, guess what the whole thing is equal to? This is going to equal to 1. If this omega is 5, guess what this is equals to? It's going to be equal to 5. If this omega is 2, guess what this is going to be? This is going to be 2. If this number is 3.5, guess what this omega is going to be? 3.5. If this omega is, say, 7, no, not 7, 9, and this is going to be 9. You follow me? Do you follow me? And the entirety of alpha 58 is application of this identity. The entirety of alpha 58 is the application of this property. Got it? Ready? Are we ready to play with it? Let's get ready to play. Okay, so that's the implication. That's the implication. Okay, so now we're gonna play with it. Okay, we have that. And of course, we also have definition. We have done the graphs. And we've done the graphs. And now let's focus on alpha 58. The first one. Okay, it is 3 raised to the power of log base 3 of 5. What does that equal to? Could I see some answers on the chat? Be brave, be confident. I'm sure you know the answer. Could you tell me? What is the answer, Francisco? What is the answer for this one? The base to the exponential and the base to the logarithm are the same. And what is the number at the position of omega? So what is the answer? What is the answer? Marcelo, what do you think of the answer? Ellen, what is the answer? 5. Yes. Great job. Perfect. How about number 2? Five raised to the power of log base 5 of 6. What is the answer? Alan, Marcelo, Francisco? Yep, you got it. You got it. Okay, so let's move forward. Move forward. Let's move forward. From number 3 to number 9. To number 9, I want you guys, please choose 3 questions to work on. 5 minutes. 5 minutes. Please choose 3 questions to work on. Five minutes. I'm not going to be watching you. You do it yourself. Okay. You choose 3 questions to work on. Maybe you want to choose 3 harder questions to work on, right? Sometimes you may see there's more than one way to do it. And that is totally fine. That is totally fine. 5 minutes. 5 minutes. Okay, if any one of you like to submit your work, that would be great. That would be amazing. That would be amazing. Okay, let me grab my cell phone so when you submit your work, I can see. I left it somewhere. You can put your answer on chat if you wish. Okay, we'll mark the number 3 through number 9. What is the answer you get? And then we're going to attack the rest of the questions. Okay, some of them is a little, it's not as so trivial. Okay, some of them they're not so trivial. Are you getting there? Are you getting there? You can submit by pronto. You can submit to the inbox. Or you can also submit your answer with on chat. Just mark the number of which question you're answering. 3 questions if you wish. Okay. Okay, do we have any answers? So what the answer to number 3? What the answer? Well, we still have 1 minute, 1 minute left. Okay, answer to number 3. What is the answer to number 3? Hello, are you guys there? Yes. Great job, Alan. 3, okay. Number 4, how about number 4? What is the answer to number 4? 10 raised to the power of log x. What would that be? This is number 4. Answer? What's the answer? Marcelo, Alan, Francisco? Instead of having a number there, now we have an x, right? The answer is x. Base 10, common log, base 10. When these two bases are same, the number before log is 1, so that's x, okay? Number 5, what does number 5 equal to? E to the power of ln 5. The answer is 5, okay? Number 6, e raised to the power of ln y. What does that equal to? The bases are the same. Before ln, that's 1, so equals to y. Okay, are we getting better at this? 7 is e raised to the power of ln of root 3. And the answer is square root of 3. Number 8. Number 8 is e raised to the power of ln of 1 over pi. And the answer is 1 over pi. Right? Is that pretty neat? All right, last but not least. Now, number 9. E raised to the power of ln1 is going to be equal to 1. So it's a direct application of this property. Okay, you get it? Now look at number 10. Number 10 is 9, right? Let's look at something more challenging. Let's look at something more challenging, okay? Let's do number 13. Let's do number 13. Okay, I'm still going to bring these properties with us. Number 13. Number 13, we have e raised to the power 2 times ln 3. What would that be? Does that equals to 3? I'm afraid not, right? Because even though the exponential base is e, the log base is also e, but there's an extra number in front of ln. What can we do? What can we do? We cannot apply that property, right? We cannot apply that property yet. What can we do? What can we do, right? This exponential base and log base must match, but the number in front of the log must be 1. Okay, now we have a 2. No, that's not going to work. What are we going to do? All right, so this is what we're going to do. Okay, I'm going to give you some hint. All right, remember when we were doing b raised to the power of m and then raised to the power of n? And that equals to b raised to the power of m times n, right? And we have that situation right now. That's our situation right now. What we have different is that we have the base is e, right? Base is e. We have m, where we have n. Okay, we have m, we have n. So what we can do is that we can write them in so many different ways, right? B to the power of mn is equals to b to the power of m to the power of n. It can also be written as b raised to the power of n and then to the power of m. There are all these different ways that you, because m times n is the same as n times m, right? So now our m, depending on which one you see it, our m, you can see this as this, e raised to the power of ln 3, and the whole thing raised to the power of 2. Do you follow me? Okay, you can regard one of these as m. ln 3 is together, okay? Don't separate them, don't break them up. ln 3 is one number, okay? So you regard this as m times n. Okay, the dot is optional. The dot multiplication is optional, but that's what it is. It's a multiplication. Now inside the parentheses, we can use the property. We can use that property with base e, and that's going to give us 3. Right? We can that the inside the parentheses give us 3, and 3 squared is equal to 9. Got it? You want to try it again? Okay. How about you guys try number 12? E raised to the power of -2 ln 5. Once again, we cannot apply this property directly. We cannot apply that property directly. Okay, we can use this, we can use similar property. Okay, Have something inside, have something outside. And you decide which one is M, which one is N, really doesn't matter. So what are we getting? What are we getting? We can write it as e to the power of ln 5 and then raised to the power of a -2. Okay. And inside the parentheses is 5. And so that's going to make it equal to 1/25. Got it? Now, 11. 11, we have half. And the power is log base 2 of 7. What are we going to do? It's not the base of for the exponential is half, right? And the base for log is base 2. 2.5 are not the same. They don't match. What can we do? Right? What can we do? Well, what you can do, we can also apply this property, but there's more than one way to do it, okay? So A over B to the power of N is equals to A to the power of N divided by B raised to the power of N. So 1/2 is A, B respectively. So this is the power, M. So what we can do is that we're gonna have 1 raised to the power of, and 2 raised to the power of, and the power is the same N right here. 1 raised to the power of anything is still 1, right? So the top is 1. And what is the bottom? The bottom, we can apply the property because now we have the match of 2. You see that? So that's going to be 7. And of course, this is not the only way to do it. Another way to do that would be, right? You can do this. We know that 1/2 is 2 raised to the power of -1. Right? So we have that situation here. Right? And so we're going to have 2 raised to the power of, when we multiply these two, so it's a negative log base 2 of 7. And we can use the same trick we have over there. And then we're going to have something raised to the power of -1. And over here is 2 raised to the power of log base 2 of 7. And then we can apply the property, right? We can apply the property we just learned right here, right? So this guy equals to 7. And so eventually we get 1/7 as well. You guys with me? You guys follow? All right, very good. Okay, so that's about the one of the very important properties. Okay, of course, number 14, 15, you guys will get it. Okay, so far we have learned the definition of logarithm. We did a lot of graph, and we have also learned this very important property. And keep going. Okay, keep going. Okay, we are going to get to 59A. Alpha 59A. If statement. Solve for X. We're gonna look at these if statement. We're gonna look at these if statement, right? Of course, we have these tools already. Right? We have these tools already. The first one. Okay, 3 to the power of X is equal to 9. It's an if statement. If 3 to the power of an unknown number is 9, what should be X? What could X be? We can solve this equation by multiple ways. Okay, by multiple ways. Okay. So I'm going to show you all these different ways. The first way, I think probably the most intuitive, is that, well, 9 is 3 squared. Everybody knows that. Right? If 3 to the power of X equals 3 squared, then X must be 2. Solved. Right? Solved. Solved. Okay? And this same technique can be used to solve all the questions from number 1 through number 12. Okay, so from number 1 through number 12. From number 1 to through number 12. Let's do up to number 8. Okay, because we're gonna do this from in three stages. Okay, number 9 through number 12. That's, and the next stage is number 13 through number 16. These are the different stages, and we're going to gradually introduce the different methods. Okay, we're going to gradually introduce the different methods. Okay. When we look at number 1, let's look at the second way. The second way is by definition. By definition. If that, right? What is our definition? That's our definition. Right? That's our definition. And our base is 3. Base is 3. So that's a 3. And so we don't need that specifics anymore. Right? And I'm going to put this in the bracket, meaning these are optional. You don't have to show these. And 3 to the power of X is 9. So this is 9. Omega is 9. And triangle is X. Right? So this is X. Right? That's X. So X is log base 3 of 9. So by definition, we got X equals to log base 3 of 9. And of course, we know that's equals to 2, right? We've done that before. Any questions so far? Any questions so far? No? Okay. Okay, so these 2 ways, let's see, if we use these 2 ways, can we attack some of the questions from number 2 to number 8? Okay, so I'm asking you guys, please choose 3 questions Please choose 3 questions from number 2 to number 8. Yeah. Number 2 through number 8. What you get? I'm looking at the chat. I'm looking at the chat. Take your time. Choose 3 questions. So what did you get for number 2? Let me check on you. What did you get for number 2? Two to the power x equals to 8. Yep. Very good job, Alan. Okay. Excellent. Because 8 is equal to 2 to the power 3. Right. So that answer, you can do it in different ways. So which way did you do it, Alan? By definition or by intuition? Oops, sorry. X equals to 3. Oh, I'm sorry. What did I do? No need. Okay, so that's okay. Very good job, Alan. Very right answer. Right answer. How about number 5? Number 4, number 5. 4, 5. Answers. Number 4, number 5. Number 4, we have 2 to the power x equals to 1/8. Number 5, we have 7 raised to the power of x equals to 1/7. Let's see what the answer. 4 and 5. Francisco, Marcelo, Ellen, what is the answer? If statement. If statement. Yeah. If statement. If statement. Yeah. What do we get for number 4? Well, 1/8 is 1 over 2 to the power 3. And this is going to be equals to 2 to the power negative 3. So in the end, x equals to what? Negative 3, right? We can also use definition. Right, we can also go by definition. Definition, where's definition? Definition is here, right? So if we use definition, what do we have here? Now it's base 2, right? And the 2 to the power of x, we have 2 to the power x equals to 1/8. Right? So omega is, so over here on the other side, we got that, right? And we have log base 2, right? I'm gonna copy the whole thing here. So we're gonna find our matches. We'll find our matches there, right? So x is in the place of triangle, so this is x, and omega is 1/8. Omega is 1/8. So that's how we can use definition, right? So from here, from when you show your work, and this is what you do, you show, right? And you're gonna write down x equals to, log base 2 of 1/8. You can just write it that way. And that's negative 3, right? That's it. Number 5, what is the answer for number 5? What is the answer for number 5? What is the answer for number 5? Do we have the answer for number 5? I'm sure you have it, right? Sure you have it. Well, 1/7 is 7 to the power of -1. So 7 to the power of x is equals to 7. So if 7 to the power of x equals to 7 to the power of -1, then x has no choice but equals to what? -1, right? So there's a 5, there we did number 5, 6, 7, 8. 6, 7, 8. Could you guys finish that? 6, 7, 8. I want you guys to work on these 3. Got it? Number 6. Number 6. Yeah? What you get for number 6? The question is that if we have 5 raised to the power x equals to 1 over 25, what will be the value for x? What would it be? 25 is equals to 5 raised to the power -2, right? And therefore, x equals to -2. Right? So you can see we use that intuitive method. We can actually solve all of these equations, right? We didn't have to bother with the definition at all. But definition is important because very soon you're going to see that, well, we have to use definition. Okay, so now 3 to the power x and 1 is equals to 3 to the power of what? 1 is equal to 3 to the power of what? 0. Yay. So x is going to be equal to what? X is going to be equal to 0. Number 8. I'm sure you get number 8. Same thing. Okay. 5 to the power x. So x has to be equal to 0. Right? X has to be equal to 0. Now, it looks like we use our intuition. We can solve a lot of equations, right? We can solve a lot of equations, can't we? That's great. That's great. Okay. And all of these we can also solve by, using definition, right? In each of the cases, right? And say, for example, in this case, we can say, hey, or from 7 to the power x equals to 1 over 7. And then we can use definition. Now the base is 7. So x equals to log base 7 of 1 over 7. 1 over 7. And that, of course, equals to -1, right? And for each of these, so I'm going to skip those and let's look at number 9 through number 12. In number 9 through number 12, we have a changed situation, slightly changed situation. So what do we have here? We have 3 raised to the power of x plus 4. Sorry, not c. X plus 4 equals to 9. Then what do we do? Well, in this situation, we also know 9 equals to 3 squared, right? So now both sides have the same base, therefore x plus 4 is equals to 2. You see the difference? Number 1 from number 1 to number 9, and then we solve for x. So x equals to what? X equals to, oops, there's a capital, -2. -2. Okay, we can certainly use definition. Can we use definition? Of course, right? From here, we can use our definition. Our definition, where's our definition? Where's our definition? Let's find it. Right, that's our definition. Right, that's our definition. In our definition, of course, the base is 3. The base is 3, right? And the 3 to the power, so the triangle is x plus 4. So that's x plus 4, right? Omega, what's omega? 3 to the power x plus 4, this is 9. So that is 9, right? So by using definition, we will get x plus 4 equals to log base 3 of 9. There. And log base 3 of 9, of course, we know that's equals to 2. So in the end, we still get x equals to what? -2. So either way, using either way, we will get what we need. We get what we need. Okay, do you guys want to try some? All right, how about you guys work on number 10? Okay, 11 and 12. Okay, so solve, so all of these are if statement. So 5 raised to the power 2x plus 1 equals to 25. 11, your turn, okay? Come on, let's do it. 4x minus 3 equals to 49. And number 12, 2 raised to the power of 3x plus 2 equals to 16. Okay, your turn. Because I want you to still see the examples. We have number 9. Try number 10. 11, 12. You have more than one way to solve the equation, right? Choose the one that you feel most comfortable. So now, did you get it? All right, so let's look at this one, right? On number 10, look at that, right? It equals 25. 25 is 5 squared, right? And then we're gonna get 2x plus 1 equals to 2. The base is the same, the power must be the same because the output are the same. So subtract 1 on both sides. So in the end, you get x equals to what? Half. Is that right? Subtract 1 on both sides and divide both sides by 2, yeah? Okay. Number 11. Let's see, what do we get for number 11? Well, 49 is equals to 7 squared. Right? So by this point, and you're gonna have 4x minus 3 equals to 2. Right? Solving for x by adding 3 on both sides, divide both sides by 4, and we get 5 over 4. Getting easier, isn't it? It's getting easier, isn't it? You can also use definition for sure. You can also use definition for sure, but we're using the most straightforward way to do it. Okay. And the number 12, let's look at number 12, right? We have 16. 16 is 2 to the power of 4. So now, same base, the power must be the same since their output are the same. And in the end, what does x equal to? Subtract 1, divide by 3, so x equals to 1. Wow, we did so many questions, right? Didn't we? Let's look at the group of 13 through number 16. 13 through number 16. 13, we have 2 to the power of x is equal to 0. It says if the output of 2 to the power x is 0, what is the input x? What do you do? Can you write 0 as 2 raised to the power something? You'd be thinking, right? Because we just use that technique. Obviously not, you can't. Okay? I'm just telling you, you cannot. You can keep trying, you're not going to be able to find it. Okay? So when we use certain technique, we still we must be mindful. We must be mindful. Okay, we must be mindful. So what is the solution to number 13? What is the solution to number 13? What is it? What is it? What is it? Ellen? Marcelo? Francisco? What is it? What is it? We have learned two ways, right? One is by intuition, the other one by definition. And what have you discovered? What have we discovered? Well, we're running out of time, but let me give you the answer. The answer is that if 2 to the power x is 0, the answer is no solution. Why? Because 2 to the power of x is always positive. Remember when we're doing the graphing, we're talking about the domain and range. 2 to the power of x is larger than 0 for any real number x. For any real number x. No solution, not in a million years, not in a million years, not in a trillion years, no solution. So when we are solving these equations, we must be mindful of the domain and range each function has. Right, that's why we did the curve. We did the curve. Now number 14. Mindful, okay? Always thinking what you have at hand, right? That curve, those curves we have graphed. 2 to the power x equals to 7. Well, 7, it cannot be written as 2 to the power of something, isn't it? Is that true? Actually, that's not true. That's not true. Not after we have, not after all we have learned. It's hard. Okay, if this were 8, we know what to do. Right now it's 7. What can you do? Okay, I'm going to show you the first way to do it. The easiest way to do it is by definition, of course. Right? So your x is simply equals to what? Log base 2 of 7. That's it. Definition. Okay, using definition, it always works. But then you say, I want to look at, I want to see the possibility of, but if you insist, okay, I want to get 2 to the, I want to have 2 to the power x equals to 2 to the power something. Can that be done? I will tell you, yes, it can be done. It can be done. It's not easy, but it is easy. It is not easy, but it is easy. So what is that tool we can use? Right here. Okay, because 7 is equals to 2 raised to the power of log base 2 of 7. Okay, so in that case, you also, of course, you get the same answer. You're gonna get the same answer just by a slightly different route. You can still do it. Okay, so the two techniques we just talked about, right? In some cases, you need to be aware of the domain and range, and you always have the answer, right? And both methods will work. Okay. In some cases that they, 40, like in this case, 49 is 7 squared, right? And 25 is 5 squared, and so on and so forth. Even in those cases, it's not easily, it's not easy to find, but because of this tool we have, we still can. Okay, so now take a second look at this expression. Take a second look at this expression. Remember, omega needs to be positive, but unspecified. So omega can be any positive number. This means that any positive number can be expressed as an exponential form with any base larger than 0, not equals to 1. You can express any positive number. We can express any positive number in exponential form. Okay, so let me write it down, that word. Okay, so let's look at the other implication, right? What is the implication? We have asked that question, right? The other implication that I'm going to put it as a note for the closure of today's lecture. Okay, the other implication, okay, a positive number, omega is a positive number, right? Say any positive number omega, okay, such as, say, omega. Say omega. Can be expressed okay, in exponential form with any base B. And of course, base B has to be larger than 0, not equals to 1. This is tremendous because you can write any positive number in exponential form. And so this is the other important implication of that statement. Okay, so by this time, I think we reached the end of the class, and you guys should be able to do everything up to 59A. Regarding the end of semester plan, after this week, we have 2 more weeks. Okay, 2 more weeks. This week, you're gonna have 2 quizzes. Next week, you're gonna have only 1 quiz. Okay. On the last week, week 16, you will have, we still have Monday class. I will review with you guys. Okay, I will review with you guys next Wednesday and Monday on this week 16. And the last day, which is on Wednesday, I will give you the final exam. So you're gonna do it online. So that day there's no class, and you'll be working on, you have a couple days. You don't have the whole weekend on your final exam, okay? You have at least Wednesday through Thursday. Okay, I might give you Tuesday as well if the test is ready. Okay, so you have a couple days, 2 days minimum, 48 hours to complete the final exam. Still 3 attempts. Okay, and then I will give you more information regarding whether start on Tuesday on the week 16th or starting on Wednesday. All right. So I will see you guys on Wednesday, if not sooner. You have a great day. So we're close to the end of the semester. Just tough it out, and you're going to be doing fantastic if you just work hard, finish the course material. Thank you very much, and I will see you guys on Wednesday.